Good afternoon. This is my third attempt actually to recording these videos. Okay, so we have here our sneaker modified version 5. So here in input 1, I recall a library called RubyDate. This library is full for changing date and play with the date values. So I run the suppress package startup message. That means, as you can see, sometime you got an warning message and it looked ugly. So it will allow me to avoid this message. And then I upload the data file to our notebook. And as you can see here, some what's going on here. And then I attach the sneaker. And then I clean the data set here. So as you can see, the sale price and retail price, I convert it as numeric values. Also, I remove the $sign with the G sub. And for the date, I change those value as a date from the character values. And I create one new column, it called day release. So day release means how many days pass since it released. And then also I rename the order date column and I create another new column from the order date. And actually it means how many days pass from since the order. I didn't change shoe size column. I only a minor change. I just changed the dot with underscore. And also same thing happened with sneaker name and buyer region. So for this model, I didn't change the values, but later when I will use the multiple linear regression, probably I will change those value. But for now, I keep as it is, the sneaker name and buyer region. We have here 51 state and 51 sneaker name. And then I create 3 new column: bought for less than retail price, bought more than retail price, and bought at retail price. So if you look closely at the argument, as you can see, the sale price is less than retail price. It will show 1, otherwise it's 0. If sale price is greater than retail price, it will show 1 other than 0. Otherwise 0. Then sale price is equal to retail price, then it will show 1, otherwise 0. Those are 3 new columns I create from this sale price and region retail price. So I create a new data frame from older data frame. I choose a few column: brand, sneaker name, shoe size, release date, day release, retail price, order date, day order, buyer region, bought for less than retail, bought more than retail, and bought at retail. Okay. So here our new data frame. As you can see, there are a few new column: the brand, the sneaker name, shoe size, release date. Our new column is day release. How many days pass actually since the shoe sneaker is released. Then the retail price, as you can see, is like only 220. without the dollar sign, and it is numeric values. And another new column created, day orders, 243 days since the order date, and the sale price is 1,097. That means what? The retail price is $220, and the sale, the sneaker sold at 1,097. That means it more than the retail price. And the buyer region is California. That means it was sold at in the California. So as you can see here, is it bought less than retail? No, that means it's 0. Is it bought more than retail? Yes, that means it 1. And is it bought at retail? No, that means 0. So always between three column, always there are only one column should be same, and other will be 0. Okay, so if you summarize the new data set, as you can see, there are 2 brands, and there are sneaker name, most like 11,043 sneaker name is Adidas Easy Boost 350 V2 Butters, and so on. Okay, shoe size, I'm not gonna emphasize on shoe size, but look closely at release date. The minimum is 27/6/2015, and the maximum is 7/2/2019. That means the recent date and the oldest date here. The day release is, the minimum is 37, maximum 362, and the retail price is, if you look closely, the minimum retail price is $130, maximum is $250, and the average price is $220. That means most of the sneakers retail price is $220. And the order date, the recent and oldest date, minimum, maximum. And then the sale price is minimum $186, maximum $4,050. That means some of shoe actually say sold at 186. Some of shoe sell at 4,500. And the median is $370. Most of the shoe sold at $370. The average selling price is $446. Okay, so, and then for the buyer region column, as you can see here, the highest selling location is California, and the second place goes to New York, and then Oregon, Florida, and so on. There are 51 states. And for our 3 new column, as you can see, definitely there are only 2 values. That's why it's minimum 0 and maximum 1. But if you look closely at the mean, if you look at the bought more than retail price, there are 99% data following this column. That means 99% sneaker actually sold at more than retail price, but less than 5% sneaker actually sold at less than retail price. Probably something happened, maybe the shoe was damaged, or maybe it was the shopkeeper actually give a heavy discount, something like this. And also some shoe actually sold at retail price, it's less than 3%, 0.3% actually. And if I visualize the data, I didn't run the pairs because it takes time, but you can comment the remove the comment sign, the pound sign, you can run also in your machine. And if I plot the sneaker name and sales price, as you can see here, the Nike Air Max 90 of white is a higher price. Also, there's only three shoe names, sneaker names show here. Also, you can show all of the sneaker names, but I'm not gonna doing this right now. So you have an idea who there are one outlier is like $4,000 is falling in the middle. And then if I plot by region and sales price, as you can see here, there are like 51 column here. All not all the column names show here. There are only 6 columns show: Alabama, Florida, Iowa, Michigan, New Mexico, and Tennessee. Also, you can show the column name in the below, but I'm not gonna doing this right now. Okay, now our model decision tree making. So I create a new data set from my older data set, and I named it new sneaker 2. And then I split it to 80 and 20% to test and train data set. And then I recall 2 new library, rpart and rpart plot, from our previous homework assignment. So you know what is the library useful for. And then I make a decision tree. And as you can see, the name of the column here, and then our training data set. So our dependent variable is sales price, and I choose a few column to predict our sale price and train the data set. I choose sneaker name, day release, bought for less than retail, bought more than retail, bought at retail, by region, and day order. So my goal is, if you given the sneaker name and when the release date, when the order date, how many days pass on since the release, how many days pass on the since order, and then the location, can we guess the sales price, or can you predict the sales price? Let's see. So as you can see, there are number of rows 79,964, and it's a messy data because I'm not gonna explain the training data set. And if I plot this data into a decision tree, the result is here. Also, there are some overplotting because there are 51 state and 51 sneaker name. That's why it's all overplotting, but it's not gonna hamper our decision tree prediction. So as you can see, if I run the prediction data set to predict the data set, let's say based on given, actually it's a five factor we took: sneaker name, day release, and the buyer region, day order. Can we guess or can you predict the sneaker sales price? So I choose the sneaker name is one of 51, Adidas is Boost T50, and the day release 200 days since it released, and it's also bought more than retail price, and the buyer region is California, and the day order since 100 days. So can you predict the sales price? Yes. So if we run the prediction, it might be sold at $400. So this is our prediction model. Okay, I'm gonna run it again. Restart and all. As you can see, it's 390. If I change the data to California to New York, is it change? Let's see. New York. Run. So if I change the state, it will sold at same price. If I change the shoe name, is it change? Okay, this one. I choose the new one. If I change this, could it change? Let's see here. And then, okay, now you can see the shoe selling price prediction is changed. It's now $1,188. So we create a successful decision tree model. Later, we will test our accuracy rate. We can use a correlation matrix, but right now I'm not gonna do this, probably later. Okay, so if you have any question for this model, please ask me. Also, I will upload this into my GitHub. You can ask there also. You have you can see a discussion poll into my repository. You can ask there. Also, you can ask me in WhatsApp group chat. I will upload this to YouTube. You can ask me there too. Thank you so much. Have a nice day.